12 is similar to this, except the littler fractions are in the denominator of the big fraction. Parentheses on your little binomial, parentheses on your larger binomial. I want to get rid of these two little denominators. So I have to multiply by 3 plus x and 3. Top and bottom have to be identical. Okay? So in the top, I'm going to just bring the 3 out front. So 3x, 3 plus x. Down here, this fraction times this stuff, the 3 plus x is canceled. That's why we did it. Okay, so 1 times 3 is 3. Then this fraction times this, the 3's cancel, and I have negative, and be careful. That negative sign is going to apply to both of those. Careful, careful, careful. Okay, now, I can't reduce this because of this. If it were 3 times this, yeah, I could. But if it's being added or subtracted, no go. Okay, so let's just simplify a little bit here, a little bit further. I'm just going to leave the top how it is. And down here, this is 3 minus x. Remember, this gets distributed to both. So the 3's cancel, so I have negative x. Now here, because now everything's being factored, the x's are going to cancel. Don't lose your minus sign. Okay, so we have the limit as x goes to negative 3 of, if you want to, you can write it like this, 3 plus x over negative 1. Or you could write it as just negative 3 plus x. Okay? Because it's a 1, you don't need to have a fraction. Just make sure the minus sign gets applied to both terms in the top. Okay, so if I let x equal negative 3, I'm going to have 3 minus 3 equals 0. Did I screw it up? Yeah, no, that's right. Well, you do all that work and it ends up equaling 0. That's not very satisfying. Okay. Ouch. Okay, this one is a little dicey. I don't know how much algebra you remember, you know, if you have your summer brain on or whatever. Okay. Now this one, it would look like, if I let x equal 5, you would have 5 minus 5, and then the square root of 9 is 3 minus 3, so it's 0 over 0, undefined. So we have to simplify this. Okay, parentheses on our binomials. Now, this is not a compound fraction like the other ones, so what I want to do is, I can't factor anything the way it is now. This is where your eyeball should go. I don't like that. No, neither. So, I'm going to multiply by the conjugate of this. Do you remember what conjugates are? I don't know if you do or not. I'll show you in a second. Okay, so top and bottom are going to be identical. Okay, just a little side thing. Okay, a conjugate just means the middle term is different. So the conjugate to x plus 5 is x minus 5. The conjugate to 3x minus 1 is 3x plus 1. Okay, so only the middle term changes. Here's why conjugates are so helpful. If you multiply conjugates, the middle term goes away. Because look what happens if I have x plus 5 and I multiply it by its conjugate. X times x, x squared. X times negative 5, negative 5x. Then it's 5's turn. 5 times x is 5x. And 5 times negative 5. Those are going to cancel. So you have x squared minus 25. Okay? So, and this would be, if you were factoring, that's what I say, a difference of perfect squares. Okay? Because we know the square root of this, we know the square root of that, and it's a subtraction. And it factors into the two conjugates. Okay, so if I want to not have a middle term, like if I multiply this by, say I multiply by this, okay? If I did this, what's going to happen is this times this will just give me x plus 4. The square roots will undo each other. But then I'm going to have negative 3 square root of x plus 4. And then another negative 3 times the square root of x plus 4. It's going to give me negative 6 square root of x plus 4. So I'm still going to have a square root. And then I would have a positive 9. That's okay. But I'd still have a square root. So it just makes it worse. So if I do the conjugate, I don't have that middle term. Okay, so we have our limit as x goes to 5. Okay, now you're just going to FOIL. Remember, this guy times both, then this guy times both. Okay? Don't make it all fancy first thing or out of whatever. Okay, x times that is going to be x times the square root of x plus 4. Now if you put a little doohickey, sometimes that helps keep it from having other stuff creep into the radical. Okay, then x times 3 is just simply 3x. Then negative 5 times that square root is negative 5 square root of x plus 4. A little doohickey. Negative 5 times positive 3 is negative 15. Okay, well that's not that great. Okay, now down here, this times this, okay, if you have the square root of x plus 4 times the square root of x plus 4, that's x plus 4 to the 1/2 times x plus 4 to the 1/2. Oh, that's too confusing. Anyway, it's going to be, it's going to be x plus 4 to the 1/2 squared. Or when you raise a power to a power to multiply, well 2 times a half is just 1, so you're just left with what's in the radical without the radical sign. So this times this gives you x plus 4. Okay, then we have 3 times our radical. Then we have negative 3 times our radical, which is why we chose to use the conjugate. Now notice I'm not doing conjugate inside the radical. I'm doing the conjugate of the bigger binomial. Okay, then negative 3 times 3 is negative 9. Okay, so let's see where we are now. Limit as x goes to 5. Okay. Well, that's kind of a mess on the top there. Let's just leave that as it is. Okay, now down here, you're going to have x. These two are going to cancel. And then you're going to have minus 5. Okay. I don't know if you guys can pick it out, but I made a mistake. Not a mistake. I didn't do anything incorrectly mathematically, but I didn't help myself. I didn't need to multiply those two. Okay? So if I go back to the way that it's written before I multiplied those factors and leave it in factored form, now you can see you're going to be able to cancel the x minus 5s. So I did that intentionally, actually, because if you find yourself kind of lost in a problem, step back and say, okay, what was I doing again? Oh yeah, I need something to reduce. And if you look at this and it's like, okay, nothing's going to reduce with all of that garbage, you go, wait a second, where did I get this? Oh, up here. This times this. And just factor it again, rewrite it. Okay? Hopefully that made some sense. Okay, so this is just going to be square root of x plus 4 plus 3. So that's just going to be square root, put a 5 in there. So square root of 9 plus 3 is 3 plus 3 is 6. Number 14 is going to be similar to this, except I think the radical's in the numerator. Yeah. Oops, that just went overboard. Those bells. Okay. Okay. All right, so again, I can't cancel those 3s. That's not going to happen. Parentheses on your binomials. I want to get rid of the radical up here, okay, and see if something cancels. So I'm going to multiply by the conjugate of this. So it's going to be the square root of x plus 6 plus 3. Top and bottom have to be identical, so it's worth 1. Okay? Doesn't look like a 1, but it's 1. Okay. So now, since we did the previous problem like kind of the long way, I'm not going to make that same mistake again. I'm going to leave this factored. Now in the top, I'm going to actually multiply it because that's how I get rid of that radical. So square root of x plus 6 times the square root of x plus 6 is just x plus 6. Okay. Then you're going to have this times 3. I'm going to go ahead and write this out. I normally wouldn't. Okay. Now it's this guy's turn. This times this. So negative 3 square root of x plus 6. And then negative 3 times 3 is negative 9. And down here, I'm just going to leave this in the parentheses. Don't FOIL it. If you do, then it'll just take you an extra step to fix it. Okay, so these two cancel. That's why we chose the conjugates. Okay, so I have my limit as x goes to 3 of x, that's this guy, and then 6 minus 9 is negative 3 over x minus 3 square root of x plus 6 plus 3. Parentheses on your binomial. Those are going to cancel. So I'm going to have the limit as x approaches 3 of 1 over square root of x plus 6 plus 3. Okay, so that's going to be 1 over 3 plus 6 is 9. 1 over square root of 9 is 3, plus 3 is 6. All right, so that's that for finding those limits. Okay. Okay, I'm going to post a practice quiz on limits, okay? And then I will post the solutions to it so you can check, and then I'll actually post a quiz on limits. So that's it for the limit stuff. Now we get to do the real calculus stuff, which is great.